This video is unrelated to optimization directly, but is in support of the third problem in the assignment, which has to do with limit analysis of frames, and for that we need to see how to construct a B matrix for frame members. So let's look at a frame. Each joint has 3 degrees of freedom, which we can think of as X translation, Y translation, and rotation. Let's take a member. We look at 2 coordinate systems. One is a global coordinate system and one is a local coordinate system with the local X aligned in the direction of the member. And if we see what the relationship is between displacements in the local and global coordinate system, we get this matrix. And we've seen in the past how to construct such matrices by seeing what the matrix does to 1 0 0 0 1 0 and 0 0 1. So let's call this matrix T, and so for the whole member we can assemble the transformation as the local displacement equals T times the displacement in global coordinates. Now let's orient ourselves in the local coordinate system, and in this local coordinate system, suppose the member that is originally horizontal assumes a deformed position like that. And let's draw the chord, which is a straight line connecting the endpoints. And let's look at these 3 internal deformations: the linearized change in length, the rotation of one end relative to the chord, and the rotation of the other end relative to the chord. Now the chord rotation itself we'll call psi, and we can see from geometry that psi is nothing but u2y in the local coordinates minus u1y in the local coordinates divided by the length of the member. So we can put all this together and relate these 3 internal deformations q1, q2, and q3 to the displacements in the local coordinates by a 3x6 matrix. Q1 is just u2x1 minus u1x1. Q2 is u1 theta minus psi, so that determines the second row of the matrix, and similarly Q3, the third row of the matrix. So we'll call that T sub SS. So if we draw a Tonti diagram, now UL is related to U in this way, and Q is related to UL in this way. We can think about what the corresponding internal forces are that correspond to little q, and those are the axial force and the 2 member end moments. So we can construct the rest of the Tonti diagram. And what is the matrix E? Okay, we can work it out to be EA over L, and 4EI over L, 2EI over L, and so on. But what we're really interested is in the B matrix for limit analysis. The E doesn't come into the picture in limit analysis. So B is a composition of the T matrix and the TSS matrix, like this. And you see that the strength constraints will be applied on the internal forces Q2 and Q3.